What's up, 20-1? Second lesson here for the rational expression and reciprocal function unit. Today we're looking at multiplying and dividing rational expressions. So last time we talked about what rational expressions are. They are some sort of fraction with a polynomial on both the numerator and the denominator. Those functions, because they are kind of like fractions, follow all of our fraction laws. So what we're going to look at today is multiplying and dividing rational expressions, which is essentially just the same as multiplying and dividing fractions, except for things look a little bit more complicated here. So multiplying rational expressions. Here I kind of outlined some steps that you can take to multiply out rational expressions. So the first thing you want to do, if it's possible, is to factor all numerators and denominators. Once you've done that, you are just going to eliminate the common factors from both the numerator and the denominator, and your final answer should also state restrictions. Now, I guess part of this is assuming that you know how to multiply fractions. And so, for example, remember if I had like 1/2 times 3/4, the way to multiply fractions is just straight across, right? 1 times 3 is 3, over 2 times 4 is 8. Really, I can just write these as if they are over the same, like part of the same fraction. And then I can simplify, multiply, and then simplify if I need to. So let's take a look at what that looks like here. 3 over a times a squared over b. Again, I can really just write those as if they are over, like both on the numerator and denominator. So this would be 3 times, I'm just going to write this out, a times a over a times b. So now I want to simplify. And so when we're simplifying here, essentially what we're doing is we are dividing out a common term from the top and the bottom. So what's common on the numerator and the denominator? Here, it would just be an a. So I can cancel out an a on the top and the bottom. Really what I'm doing is dividing each side by a, and that's what simplifies it. So my final answer in simplest form would be 3a over b. I need to state my restrictions. And my restriction should always come from the denominator before I canceled out terms. So what's going to happen here is a cannot equal 0 and neither can b, because restrictions are based on where the denominator cannot equal 0. So I would say a and b cannot equal 0. And there is my simplified final answer. Okay. Let's take a look at b here. So 4x squared times 9y3 over 3y squared. I'm not going to say that out loud. What I can do is multiply my top and my bottom together if I want. So I could multiply my coefficients. So 4 times 9 is 36. And then x squared y cubed would just kind of be written together like that, because they are all technically just being multiplied over 3y squared times 8x to the 4, so 3 times 4 is 24, times x 4y squared. And now what I need to do is cancel out like terms on both the top and the bottom. So there are 2x's here and 4x's on the bottom, so I could totally get rid of 2 here and be left with 2 on the denominator. 3y's on the top and 2y's on the bottom, so 2 of these y's would cancel out with 2 of these, and I'd be left with 1. And also 36 and 24 could be simplified to a fraction because they can both be divided by 12. So 36 divided by 12 would be, the numerator here would be 3y over 24 divided by 12, which is 2x squared. And so that's my rational expression after it's been simplified after multiplication. The other thing I need to do is state my restrictions. So for this, the denominator cannot equal 0. So x and y could not equal 0. Okay. Next part, x squared minus 3y minus 10 over x squared minus x minus 56 times by x plus 7 over x minus 5. Now, looking at these, we cannot just be like, oh, let's start canceling out, there's an x squared here and an x squared here, and one of these with 2 of these. That doesn't work now, because these terms are being added and subtracted. While in this previous question, everything was being multiplied. So when things are being multiplied, you can cancel out like terms from the top and bottom. But if things are being added, like this is just a regular polynomial, I can't just cancel out terms yet. So what I need to do is I need to factor that. So let's factor this. This is a polynomial where a is equal to 1, so I can take a shortcut. I'm looking for two numbers that multiply to negative 10 and add to negative 3. So that would be x minus 5, x plus 2, over the denominator, which needs to be factored. Again, I can use a factoring shortcut for that because a is equal to 1 in that trinomial. So I'm looking for two numbers that multiply to negative 56, and add to negative 1. So that would be x minus 8 and x plus 7. Multiplied by this guy, which is already factored. So I'm not going to change that at all. So really, I could just say, well, I'm multiplying straight across. So now these guys are all just being multiplied by each other. So I can cancel out like terms on the numerator and denominator. So x minus 5 can cancel out with this x minus 5. X plus 7 can cancel out with this x plus 7. And that's it. So simplified after the multiplication would be x minus x plus 2 over x minus 8. Still need to state my restrictions, so I would say x cannot equal, remember you just make each of these equal to 0, and it's really the opposite of what it appears. So x cannot equal plus 8, it cannot equal negative 7, and it cannot equal a positive 5. And that would be my simplified answer, as well as the restrictions being stated. Okay, I will do one more for multiplying, and then I want to take a look at dividing. So here's two examples. They're both going to be solved with the same sort of strategy. So which one looks more complicated? Let's go to E because I haven't factored with that particular strategy yet. So E, again, if I'm going to multiply, I can't just start canceling things out here because these are trinomials that are being added. I need to factor them. So the first numerator, a is equal to 1. So I'm looking for two numbers that multiply to negative 12 and add to negative 1. So that would be x minus 4 and x plus 3. The denominator here, x squared minus 9, hopefully you can recognize that can be factored with the difference of squares. So that would be x minus 3, x plus 3, multiplied by, which is again just the same kind of fraction. The numerator of the second fraction can also be factored with a equals 1, so shortcut. I'm looking for those two numbers that multiply to 3 and add to negative 4 would be x minus 1, x minus 3. That multiplies to 3 and adds to negative 4. This denominator here, first thing I can do is remove a GCF. So let's remove a x, and I'd be left with x minus 4. And those can't be simplified any further. So if I multiply, really, these would all just kind of be over the same denominator, and they're all being multiplied together. Now all of those terms are being multiplied. I can cancel out like terms on the top and bottom. So an x minus 3 can cancel out with an x minus 3, x minus 4 with an x minus 4, x plus 3 with an x plus 3, and that's it. So I would be left with an x minus 1 over x. My restrictions here are that x cannot equal, and I need to go make each of these equal to 0 and solve. So this would give me a plus 3 and a minus 3. So x cannot equal plus or minus 3. From this one, 0. And from this one, a positive 4. So that would be the final answer there. Okay. So multiplying, pretty straightforward. All you need to do is factor and then simplify common terms on the numerator and denominator, because when you multiply fractions, you just kind of write it over the same fraction. Dividing rational expression. So a little bit more complicated here, as well as figuring out the non-permissible values here is a little bit more work. So I wrote out some steps here. First step for dividing rational expressions, and pretty much anything that you're going to look at for rational expressions, the first thing you want to do before, whether it's add, subtract, multiply, divide, or solve, is factor out the numerators and denominators. Once you've done that, remember, we never divide fractions. What we do is we change it to multiplication. And the way that we do that is we keep, switch, flip. So keep the first fraction the same. Okay. Switch the division to multiplication and flip the second fraction. Okay, that's what it means by keep, switch, flip. Once I've done that, it's just a multiplication question. So same thing as we've done before, simplify out common terms on the numerator and denominator, and your final answer should also state your restrictions. So let's go take a look here. First step above there was to factor. So I'm going to factor the numerator here with the shortcut a is equal to 1. So I'm looking for two numbers that multiply to negative 20 but add to negative 1. That would be x minus 5, x plus 4. The denominator is x squared minus 6. So I can take out a 6 and I'd be left with x minus 6. Or sorry, I can take out an x and I'd be left with x minus 6. I'll leave this as division for now because I'm going to just factor. So the second part here, this trinomial on the numerator, I'm looking for two numbers that multiply to 20 and add to 9. That would be x plus 5, x plus 4, over the denominator, which is x squared minus 12x plus 36. So again, I can use that shortcut. A is equal to 1. So looking for two numbers that multiply to 36 but add to negative 12. And that would be x minus 6 and x minus 6. Once I've factored everything, then I can do my work. So first thing I got to do is I got to keep this fraction the same. So I'll write that down here. X minus 5, x plus 4, x minus 6. I'm going to switch this to a multiplication sign, and I'm going to flip this. So this would be x minus 6 on the numerator, because I'm flipping this whole thing, and then x plus 5, x plus 4 on the denominator. So once I've done my keep, switch, flip, this is just a multiplication question, same thing as we would have done previously. So I'll just start canceling out like terms. X plus 4 and x plus 4 will cancel each other out. X minus 6 cancels each other out. And I think that's it. Because x minus 5 and x plus 5, they can't cancel each other out because they're opposites. And the x on the denominator also can't cancel out. So this becomes x minus 5 over x times x plus 5. Okay, that's simplified. The last step here is I also have to say what x cannot equal. Now, we said we'd take the denominator here. So, really, if I change this into a fraction, it would look like this. Okay, if I write these two rational expressions being divided as a fraction. So what's on the denominator here is actually all three of those terms. So my non-permissible values come from all of these guys combined. So from here, x cannot equal 0. From here, x cannot equal a positive 6. From here, x cannot equal a negative 5. From here, x cannot equal a negative 4. And these guys are both x cannot equal a positive 6, which is already there. So that would be my final answer once it is simplified, with my including my non-permissible values. All right, I'm going to do one more division, and then maybe a question that combines both division and multiplication. So let's take a look at. I think B is straightforward. If you want to go look at B, I'll post the answer. It's online in my notes. Take a look at that. I'm going to go through C just because it kind of looks different, although it's really just asking the same thing. So what I'm going to do is I'm actually just going to split this up for myself. At the same time, I'm going to factor. So really what this is saying is this is being divided by this. So this is my first fraction, and I'm going to write it in its factored form. So x squared minus 4, the numerator there is a difference of squares. So I could separate that into x minus 2, x plus 2, over x plus 3. And then I would divide that by this second fraction, which I also want to factor. So from the numerator here, I could take out a 2, and I would be left with an x minus 2. And the rest of this denominator, when it's factored, I can use a shortcut. So I'm looking for two numbers that multiply to -3 and add to +2. So x plus 3, x minus 1. Once I've factored that, then I can do my keep switch flip. So I keep my first rational expression the same. So x minus 2, x plus 2 over x plus 3. I switch my division to a multiplication sign, and I flip this second fraction. So on the numerator now becomes x plus 3, x minus 1, and on the denominator 2x minus 2. And then now this is a multiplication question. I can just cancel out like terms on the numerator and denominator because everything is being multiplied. So x minus 2 on the numerator and denominator cancels out. X plus 3 on the numerator and denominator cancels out. And that would be it. So on the numerator, I'm left with x plus 2 and an x minus 1 all over 2. Okay? Can't cancel these 2's out because this is an x plus 2, not just a 2. So that's as simplified as this can get. The last thing I would need to do here is include what x cannot equal. Remember, all three of these guys create my non-permissible values because they're all on the denominator under this original numerator. So from here, x cannot equal -3. From this binomial, x cannot equal a +2. From here, x cannot equal -3, which is already written, and x cannot equal a +1. And so simplified, there is my final answer. One more question I'm going to do, just a question that kind of combines everything. Where is it? Maybe not. Actually, I'm going to leave it. Okay, if you have any questions, please fire me an email. If you want to see how the questions that I skipped are done, they are all written out for you in the note pack for you to look at. And when you're ready, go do some of the homework questions on homework number 2 on multiplying and dividing. And once you feel comfortable, you can go complete the quiz. Thanks for listening.